Well, good afternoon and welcome back to the final webinar for today. AIEC Webinar Weeks aims to address today's industry challenges and opportunities along with solutions and tips on how to overcome them. A couple of housekeeping items. Our presentation will last about 40-45 minutes. We'll leave 10 or 15 minutes towards the end for questions and answers. Please use the chat function to submit those questions to us. You can direct those questions to AIEC from the drop-down box. Those questions will come to Brian and myself, and we will moderate those questions to our presenter today. So yeah, just lost direction here. A couple reminders for those of you that this is your first webinar. We do have all of our previous webinars in an archive. If you visit aiec.coop/webinar weeks and click on the archive, you'll be able to view those. And we're always open to feedback and suggestions for future content. So drop us a line if you have a great idea. We'd love to hear from you. And with that, I'll turn it over to Brian.
All right. Real quick reminder that this session does qualify for PDH credits for our professional engineers. So if you have not been on any of our previous sessions, shoot me an email and just say, hey, I'm a PE, I would like the PDHs, and I'll hopefully get those certificates out late next week after our final round of webinars wraps up. So with that, our presenter today is Wayne Kinterick. He is the Regional Sales Manager for the Midwest region at Electroswitch Corporation. Wayne has worked in the electrical industry for over 40 years with experience in electrical products, electrical power systems, industrial automation, and related services, holding positions as sales engineer, product marketing engineer, regional specialist, marketing manager, services manager, and now sales manager. So with that, I'll hand it over to you, Wayne.
Well, thank you very much, and I appreciate the opportunity to present to you folks today. Again, my name is Wayne Kinterick. I will be talking specifically today about our utility grade products, our utility Electroswitch switches, rotary switches, and I will be doing partial PowerPoint presentation and partial demonstration via another webcam that I have on a tabletop. Just in summary for the company, we're a 70-year-old company. If you haven't heard of Electroswitch, we were born out of the electric utility industry and the military. We're a vertically integrated company, so for the military, it's very important. Everything's U.S. manufactured in Boston area in a town called Weymouth, Massachusetts. And we've got some good employment in the Boston area as well as other locations, including Raleigh, North Carolina. We're split up into 8 divisions, and our primary focus is in high performance rotary style switches and joysticks and military grade controls. And we also have a lighting controls division with our Ripley and Suntech divisions. Today, we're going to specifically focus on switches and relays for the electric power industry. And those will include rotary position switches, which have multiple decks and multiple positions that can be used to switch utility grade applications and a lot of DC applications, a lot of DC style switches. This summary page here just gives you an overview of the styles of switches that we produce. I'm going to focus on the Series 24 and talk a little bit about some of the other switches that are incorporated in breaker control, lockout relays, and even auxiliary switches on circuit breakers, power breakers. With that, I'm going to just go into the basic manually operated switches for instrumentation and control switches. And that would be our Series 24. Our Series 24 features a double wiping like a knife switch contact configuration. And I'll demonstrate that in a moment. The double wiping basically means that as I rotate the switch, I'm moving a movable contact through a set of blades, and every time I make or break the contact, I wipe the action, and it provides a self-cleaning action that keeps the contact areas very low resistance, as well as providing a bounce-proof connectivity. And the switches are rated for 30 amps, and we can do multiple decks with those switches. In the slide here, you can see there are, right below the picture of the switch is an assemblage 2 and an assemblage 3. We actually have 11 different types of assemblages, and that will give you the contacting for a switch that can make it very complicated. And at this point, I'm going to go to my tabletop and show you what I just talked about here with the switch. So right now, here I am. Everybody hopefully can see my hand. And this is a typical Series 24 rotary contact switch. You'll see the deck in the back with the different terminals, and the switching action for this switch happens to be a complete rotary switch with an off and 7 contact positions. So this essentially is a single pole 7-throw switch. And that switch can be shown in a cutout, and hopefully I can show you that without too much glare. You can see the contact, and as I rotate it through the blades, there's a rotation where I've got the circuit up here. Power is coming in for this contact, and as I rotate through it, the connectivity is through each one of those 7 positions out to the terminals that it's connected to on each blade and each circuit switch. So that is one configuration of the Series 24. The other configuration of the Series 24 is an assemblage 2. And hopefully everybody can see that. I'm trying to get it as close to here as I can. If not, please speak up and I will re-show you the other assemblage. But here you can see in this assemblage, I've got 2 contacts covering 2 terminals simultaneously. And so what happens is, as I rotate the switch, I'm moving to 2 other terminals. And this essentially allows me to give multiple contact configurations on the same deck, which gives me 2 normally open and 2 normally closed contacts for every deck on the back of a Series 24 switch. So you can see how that rotates and opens and closes contacts. Without getting too complex about the switch, these contacts right now are considered break before make. So as I rotate the switch, I'm breaking the contact, and then there's an air gap, and then I'm making it again in another situation, another circuit. There are certain situations like current transformers and instrumentation where I need to have a make before break system, which means the blade is going to be a different configuration, and in fact it's going to be a little thicker so it overlaps 2 contacts. So if there are any questions on that, I can go into a little more detail, send me an email, or we can talk offline. But that's kind of the fundamentals of how these switches are usually used. And a lot of these switches are used in the military and the utility market. One of the key features of this switch is because I have a double wiping blade, a double wiping circuit, it's considered bounce proof. And that's one of the things that the military likes in their equipment, especially in their Navy ships, where there's a lot of vibration, where when there's a secure contact made, even if it's bouncing around, it's still going to have a open and close between the two blades here concept. So if I'm bouncing up and down, I'm still looking at solid contact on either side of the movable blade. So it's got that knife switch action that we like to have in a circuit. Let me go back now to my presentation for a minute. So we covered the double wiping, the self-cleaning, the bounce proof, and the low contact resistivity. There's one other area here that I want to show you, that in the back of the switch, you know, we've got basically in this series, it's an 8-position switch. So as I showed you before, I've got 8 different circuits that I have. But in some situations, I don't want to have a completely rotating switches. I want to have maybe a 3-position switch where I've got a left, a center, and a right position, and I don't want to go any farther. Well, the way to do that is with stops, circuit stops. And so our Series 24 can be configured as a 3-position switch by putting in screws in the back that prohibit the rotating part of the switch to go any farther. So that's how I configure a 3-position, a 2-position, or however many positions you want. And because of this flexibility, we have tens of thousands of designs and configurations that we can make for customers and for application. If I now go to my types of switches, you know, we talked a little bit about the Series 24 and some applications. 2 of the basic applications for a switch is to have a maintain selector for like a local remote switch or a voltmeter switch, or a spring return style switch for breaker control. And let me show you those real quickly here. So we did talk about a maintain switch. So when I move it in that position, it maintains in that position. When I come back, it comes back and is maintained in that position. But I also have what is called a spring return. In this case, it's probably I'll move it in a trip position and then it springs back to center. I move it to the closed position and it springs back to center. This particular switch has a bump-proof handle on it, so it does spring return on. Hopefully you can hear that operation. And it springs back to the center position. So those are common applications for a breaker control switch in an electric utility substation. So in these styles of switches, then we have contact decks that can be configured in many decks deep. So this gives you a nice compact control switch that you can design into a project or use for very different switch configurations and applications. One of the things that we've also done with this particular line is to incorporate the LEDs, the lighted nameplate LEDs, that allows control switches to be local enunciators, as well as electronics that could have an output on it that could give me a SCADA contact in the nameplate area. So we have typical LED configurations with 5 colors: red, green, blue, white, and amber. And that allows you to not have to have a separately wired annunciator light panel. So you locally get a mechanical switch composition identification, an LED identification, lighted for on or off, or stop and go, or for up and down, whatever you want to configure it for, as well as the different popular voltages that are used in a switch configuration. And in the utility industry, it's 24 volts DC, 48 volts DC, 125 volts DC, and 250 volts DC. Those are the most common voltages in the utility world, but we can also do it at 120 volts AC if you need that kind of configuration. The next Series 24 device is most commonly referenced to the 86 Lockout Relay. And that 86 Lockout Relay gives you the highest speed control switch on the market at 8 milliseconds for a manually operated switch. And essentially what we did was go to utilities and ask them what they wanted in a lockout relay. And they basically came back and said, we want the fastest possible tripping time, because this is essentially an emergency lockout switch that says if I've got a problem on a substation and a transformer, let's say, I want that protective relay in the substation to trip a lockout relay and disable any possible control circuit that's going into that transformer control scheme to prohibit it from energizing if there's a fault in the transformer. We all know that substation transformers are big tanks of oil out in the field area, but those are very expensive tanks of oil, and you want to make sure that in protecting a substation transformer, you don't misoperate it or switch a control into a faulted transformer. You want to make sure you send somebody out there and troubleshoot the problem for it to trip before you enable the controls back on the system. So the Series 24 lockout relay for Electroswitch is the fastest in the industry, and we've designed it to have up to 60 contacts available to do switching. And we started out at 10 decks maximum, and over the years we've been able to increase it up to 15 decks, which would give us the 60 contacts. And in that particular design, we have a compact design, a manual electric operated design, and a self-reset design in all of the popular voltages. So with that, let me do a little hands-on demonstration again and show you the lockout relay and how it operates, as well as some of the other devices that I'm talking about electrically. I'm going to go to the manual lockout relay first. Now, a manual lockout relay looks kind of like this. It's got a trip and reset handle button on it. But if I'm in this particular case, I was in the trip position and I just turned it to the reset position. Now, I cannot manually trip that switch manually once it's in that position. The only thing that I can do is wait for a protective relay that's out in the field to trip this device. And to do that, there's a solenoid here that is basically mechanically holding a spring mechanism that is energized momentarily by a system protection contact. And when that system protection contact operates, it then trips the lockout relay. So once I do that, the mechanics is the speed. So that mechanical spring is an 8 millisecond operation spring. And once that happens and once that trips, you do not want to go back and just manually reset this switch, because what's going to happen is you're going to have your trip function there and it's going to trip it again. So if you think about it, you want to make sure you go out there and troubleshoot your circuit and all the circuits associated with that to find the fault before you reset this device. This essentially is your insurance policy to make sure that no other circuit is operating until you've gone out and identified the problem. And in this particular case, now you can see this happens to be a 1, 2, 3, 4, 5 deck switch with the control deck for this solenoid. So that's a basic mechanical lockout relay, the 76 function in a substation. Now, what we've been able to do with this design is to create a version that has a couple of things with it. One is it has the LEDs that specifically tell me that when the green LED is on, that means that the trip coil is healthy and I have current flowing to the trip coil, so the relay is ready to operate. And then when I do get a trip indication, or when I do get a trip, I have an LED indication that says I'm under fault, and it matches with the flag on the relay. So if I go ahead and trip this switch, I have a mechanical flag that comes in and visually gives me a mechanical, it's called a mechanical target, and tells me that I'm in the trip position and my red LED will come on. Now this happens to be not wired to a demo, and I can show you that electronically with one of my electric versions, which I will shortly. So that's how this operation works. And over the years, we've developed a Molex connector that connects the lighted nameplate with the controls of the lockout relay. So over the years, if you have any problems with a replacement nameplate and the LEDs, you can remove that without having to pre-test and recommission this relay. In most system protection applications in the field, when you initially install a system like this, you have your system protection folks come in there and do a commissioning of every termination and how everything is wired. So this is a nice, convenient way to retest and repair and replace the nameplates and not have to rewire the whole switch and retest the whole switch with that connector. So let me do this electrically and show you how that works. I'm going to bring up here the control switch. This happens to be a remotely operated switch. So I have a local and a remote operation. So I'm going to, in a local mode, because it's electrically operated, it would allow me to manually trip and close this switch. So if I'm in the remote mode, I can electrically operate this switch and it will give it a momentary close and then a momentary open. So now I can go in and close that switch remotely. And you'll see the spring return on the lockout relay, allow it to come back to the manual position. But you can then see how the lighting and the LEDs, they're a pretty bright And so you can see them from a lot of different areas within the substation, as well as providing SCADA control or local control. And I push this in, my amber light comes on, and I can manually trip and close the breaker with the handle. In my remote mode, I can do it remotely. So that's kind of a basic functionality of a lockout relay, manually as well as electrically. So as I look at lockout relays and make my selections, one of the things that I want to be conscious of, and utilities are very conscious of, is the response time for the fastest operation of a lockout relay and the range that the coil can handle and operate within. And so many utilities specify coils that are give you a nominal value, but may fall into a lower current range or a lower voltage range that allows that trip coil to operate closer to their sweet spot, if you will, of how they may have under or over voltage conditions in their particular substations. So we have multiple coils that you can select and look at different threshold voltages, because remember, if you're looking at, let's say, a 24 volt nominal voltage coil, that coil will operate within a range from 10 to 40 volts DC, but the threshold voltage may need to be variable. So we have a couple of options for that. Same with the 125 volts DC version. There's a lot of variation in the range that utilities like to have, so that they know that if the power system is, maybe it's 125 volts DC power system, but it's got some voltage drop, and it may not actually be 125 volts DC, or batteries, maybe some battery system has a failed battery cell in it, so the voltage might be a little bit lower to trip that. You still want to be able to trip it at a threshold voltage that's within the range. And you can see at 125 volt DC level, I've got a couple of options for a 16 volt DC minimum threshold voltage that will still trip the device, or a 23 volt DC voltage that will still trip the device. It will just trip it in a longer period of time if it's not at the nominal 125 volt DC level. Okay, so we talked about lockout relays. I demonstrated the manual and the electric reset. Just to kind of go over a summary of the control circuit. In the manual reset lockout relay, my S1 contact at the top of that diagram is your system protection relay. So if you have a 5051 overcurrent relay or a bus differential 87 style protective relay for bus protection, or an 87T for a transformer system protection, that would be the output contact from that relay as your S1. And in a manual lockout relay system, the S1 is all I need to trip that coil. And you'll see what happens. And when I trip the coil, I get the solenoid to operate, and then immediately the LOR contact opens and takes the voltage off of that trip coil. If you keep resetting a lockout relay into a fault, you're going to burn up that coil. And that happens quite frequently. So one of the cautions you might want to make sure you have is to never reset a lockout relay multiple times into a fault, until you've identified what that fault is. In an electric reset lockout relay, I've got two system protection contacts, an S1 and an S2, where S1 activates the lockout relay and S2 resets the lockout relay. And that's what I demonstrated before in my tabletop. The third version is the self-reset lockout relay, and that only requires a single system protection input contact. So when it's closed, it operates, and when it's opened, it resets. So I do have one of those devices here, so I'm going to go back and do my favorite thing, which is to share and demonstrate. And now I'm going to bring my electric reset relay out, electric lockout relay up. Hopefully everybody can see the green lockout relay light here. And I can trip it, and then it'll reset. So when I hold the contact closed, it's tripped. When I let go of the contact and open it, it resets. So we've got a linear solenoid in this relay that operates the controls. And again, of course, you've got your decks of control functions in the back that will activate or deactivate the control circuits that you have wired to the back of that device. Heading back to my PowerPoint presentation. So that's kind of the fundamentals of a lockout relay. And if anybody has any detailed questions they want to ask me about this, feel free to send me an email or get in touch with me and I can help you out with that. We did talk about the lighted nameplates on most of our Series 24 devices. Just to reiterate, that those lighted nameplates provide not only local and remote enunciation with either the LEDs or a SCADA contact, but it also provides LED warnings for a standing trip. And it's just a nice compact design for conserving panel space, and it's very easy to use without any special training. So now we're going to talk a little bit about a special control switch, and this is essentially taking a manual switch and putting a solenoid on it to electrically operate it, and then to provide SCADA outputs, as well as allowing it to be manually operated or SCADA operated, and then looking at the different types of configurations you have that you'd want to have in this as a control switch relay. And this is primarily for time delay applications or automatic control applications. We do have a special CSR, control switch relay, called the TD-CSR, which is a combination of a control switch relay and a time delay function for arc flash mitigation applications. And essentially what it does is it allows you to manually walk into a substation and operate a breaker through the TD-CSR by giving yourself time to set the trip function, leave the space, have the breaker trip after a period of time, and then you can come back into the space and do your maintenance on the particular device or that breaker in that substation without exposing yourself to arc flash issues under the OSHA 70E requirements that you might find yourself involved in some areas. So let me show you what that looks like and how that operates. Now this control switch looks very similar to the other control switch relay that I had up here before, but this one is a little bit more unique in that it has a couple of push buttons on either side of the lighted nameplate. One at the bottom here called delay open, and the other one on the other side called delay close. And so this is a manually operated function, as well as a remote operated function through SCADA. So if I have a breaker that is operating fine, and I go ahead and close the breaker, I've got my indication on, and I'm ready to come into a substation room, and I want to set the trip function on this. I go up to this control panel and I want to do a delayed open. So while I'm sitting here, this happens to be a 10-second delay open control switch TDCSR. So what I do is I press the button and hold it for 4 seconds, and I'm going to get an LED that starts activating. Once I release the button, it's going to time out 7 seconds and then get a little faster after that, but it's going to give me time to leave the space and have the switch operate. Hopefully everybody noticed that did operate. Now this particular switch comes in different times versions of 10, 20, 30 on up to 90 seconds for whatever a customer feels is the desirable safe time for them to leave the room and come back in. So if they're doing maintenance in a breaker, they can go in, maintain the breaker, and then when they're done, they can do the reverse function with the delay trip close button. And so I'm ready to leave. I grab my bag, press the button, get my red LED to start timing. I start walking for the door and I say, oh, I forgot something. So I come back in there and I press the other side of the delay open button and I cancel the timing, and it allows me to, make a mistake and not have to trip that device easily by just pressing the other side of the button. And then go ahead and find the problem I needed to solve, and then go ahead and reactivate the button, hold it down for 4 seconds. The red LED will start timing for 10 seconds. I run like heck to get out of the room so I don't have to worry about closing into a breaker that potentially could hurt somebody, and it goes ahead and trips automatically. So that's the arc flash mitigation solution that we have for many utilities and industrial plants that need to have people who are either qualified or unqualified, but they still have to wear PPE, protective equipment, to go in and access those spaces. This is a nice operational way of operating that switch without trying to do something remotely or wearing PPE and having to still be in an unsafe situation. Hopefully I didn't drag that out too long. Okay, so now we're going to go back and look at our presentation again and talk a little bit about other devices that we have available for power switching. In this day and age, you can't get away from communications and internet access and operating control schemes via different protocols. In the utility industry, the most common protocol being used for communications is called DNP 3.0. And we have our capabilities that in our lighted nameplate package, we can daisy chain multiple relays and communicate back through a serial communication model that will give us trip information, breaker status, switch status, system voltage, battery voltage, and even give you the IRIG-B timestamp of the device that you have a control communications option on. So with this, you can actually map out, in many cases, control centers at substations and control rooms for utilities will have a video graphic of all the devices they have in their system and all of the lockout relays and all of the control switches and all of the breakers in a nice visual graphic format that they can monitor and do an overview and understand what's going out in the field on every substation in their network. We did talk mostly about the Series 24, which is our 30 amp control switch device. We also have a Series 31 design. The Series 31 is functionally the same as a Series 24, except that it is half the ampacity of the Series 24. So it's a 15 amp contact switch, and it's got some limitations on the number of sets of contacts available, but it functionally does the same type of things a Series 24 does. And one of the operations that we find customers looking at is to incorporate a latching switch function in which they have a switch that operates in a local remote or a normal and tagged function, or a tied and an untied function. And I'll show you that in a minute, because I just had an application for a tied and an untied function that a customer asked for. But in reality, I can show you what that is. So what I have here is a Series 31 size, and as you can see, it's about 60% the size of a Series 24. Series 24 here, frame size, Series 31 frame size here. So it's about 60% of the Series 24 size, and I can do everything that a Series 24 can do, but my contact deck is smaller, and they're rated for 15 amps instead of 30 amps. But a nice function that this latching device allows you to do is, again, with maintenance purposes, this happens to be a tagging relay, and it's marked at normal and tagged on the switch. And for those maintenance outages that you need to have where you bring contractors in who have to tag their locks on the particular devices that they're working on for safety purposes. At the supervisory level, you might want to have a tagging relay that kind of adds the final supervisory lockout tag for that particular breaker. And in this particular case, then you can have a SCADA operated tag, and in this case the tag says caution, hotline tag applied. And so when this switch is operated and has that hotline tag applied, you are the first on and last off lock, essentially lockout tag on that maintenance system for that particular breaker. And you can make sure that everybody's got their tags off, their locks removed, before you go ahead and activate this switch. And so it's a latching relay, and it latches in all of those contacts or unlatches all of those contacts that you have wired into the control scheme for that particular application. I also just had an application yesterday where a customer was looking at applying a lockout relay to tell their operators and their people that on a double-ended substation, I have a tiebreaker that is tied or untied. And so they use this as a tied and untied function that will allow them to inform people through SCADA as well as at the switch that a double-ended substation has its tiebreaker closed or open. If it's closed, that means it's tied. If it's open, it's untied. Okay, so zipping right along here, I'm going to go back to my PowerPoint presentation and talk a little bit about a few other things that you might be familiar with or see in substations and types of devices you might need to have replaced or added to your system. We do have in the lighted nameplate packaging a annunciator target relay that can be used as a high-speed solid state replacement for some older style time delay relays in the field. It's a great replacement for the old GE HAA device that's out in the field. If anybody has questions about that, I can pass some information along on that. We also have, and I know in the rural areas, you have a lot of reclosers. And we have a 3-phase trip coil monitor that can actually be used to monitor and provide SCADA input, excuse me, for each phase of a 3-phase recloser or a 3-phase breaker that has operation individually pulled operated devices, controls. So this is a good little indicator and provide you SCADA outputs for that feature. It also provides iRig-B, time stamping, monitoring of battery, and you can daisy chain up to 31 of these devices together. And it's also information is retrievable versus via communications like DNP3 or Modbus. And it's got self-diagnostics on it and some spare auxiliary inputs that are available. So if you need to use something like that, let me know. But back in the old days, there were instrument and control switches made by Westinghouse, the Type W. And the Type W is the oldest design pretty much in the US for utility grade control switches. And they were very large, and this is one of the devices that we improved upon with the Series 24. But these style instrument switches are still viable, they're still available, they're heavy duty. And this particular switch, it's one of the mainstays of the nuclear industry. The nuclear power plants have used a lot of these Type W switches produced by Westinghouse. Well, we bought the product rights and the design rights from Westinghouse for this and the Lockout Relay design switch. So we can now provide that legacy device for you in any applications where you need direct replacements, where you don't want to disturb any wiring, and use this heavy duty control switch, which gives you 12 positions. It's a lateral contact. It's not a rotary contact switch, but it gives you up to 96 contacts and can give you different key lock features. And if anybody has interest in that, they can contact me. One of the other products that we have is we use a lot of this in the military as well as heavy duty applications and in the transit, the rail transit system, is snap switches. Now our snap switch line is a more compact line, but it also is limited to 4 poles, 2, 3, or a 4-pole switch. And it essentially, for every 90 degrees of rotation, it gives me a spring coiled action and it quickly snaps into place. And I can show you that in a demonstration in a second. So it's, let's say I had a 4-pole switch. For every 90 degrees of operation, I wind up a spring, and at the end of the winding, it snaps into place, which gives me a very high tolerance for DC circuits. It eliminates arcing and faulty replacements of switches that have maybe toggle switch operation that can be slowly teased into position and burn up quickly. We use our low resistance double wiping contacts in this switch, and so it's a very highly reliable switch, and it comes in very high current ratings, into the hundreds of amps. So these switches can be very large in stature and in control scheme. And we use a lot of these switches in locomotive engine designs and in the engineer compartments. We've provided this switch to locomotive manufacturers for the last 60 years. And this was also one of the switches that was used in the Navy and the military, and they still use a lot of these switches for their applications. Real quick, I'll show that to you visually on how that looks on the camera. This happens to be a small cut in and cut out switch. This is you can see a little different circuit configuration in the back, but you'll see as I rotate the switch from cut in to cut out, I've got this dwell area, but what it's doing is it's allowing me to wind up the spring. So when I do get to the cutout point, you heard the click and it's snapped into place. Same thing in other directions. So this happens to be a 2-position switch at 12 o'clock, and at 3 o'clock, I've got a cut in and cut out. I can build a deck out quite a bit, and switches like this can be used for voltage selection switches, and they can be designed into hundreds of amps of current for each of these designs. So that's another style of switch that we manufacture a lot of for the military. Looks like I'm starting to run out of time, so let me just go back to the PowerPoint here and look at, if you're looking at Electroswitch devices and switches, one of the things that we do, because we are such a custom shop, is we will give you a drawing that configures and allows you to identify the switch that you want to use in your design so that you can be assured that it's the right style for the right application. And so what we provide is a drawing that gives you the switch type, the part number, the panel drilling information, the depth behind the panel that you're going to need to mount the switch. There's a handle outline diagram, an action designation, whether it's maintained or spring returned or other. There's the handle position that you're looking for and the legend associated with that, what it's going to say. We can do jumpers. We can basically wire and configure an electrical circuit behind the switch and what should be in series and in parallel, and wire the switch with jumpers as you require. We do custom engravings, so we can tell you what the engraved nameplate looks like. Looked at the blade diagram of what assemblage you select here. In this particular case, this is the assemblage 3, and a drawing revision number. And then most importantly, the X chart to tell you, depending upon the number of decks that you have, what circuit closures you have in what positions, so that you can essentially engineer a switch to your exacting requirements. That's kind of summarizes my presentation for this utility style switches. Again, we've got multiple style of other switches. In this particular picture, you can see the Series 102 auxiliary switch, and that is typically used by OEMs who put auxiliary switches on their circuit breakers. So if you've seen the terminology 52A and 52B, this mechanical switch is your 52A and 52B contacts off of that breaker that is mechanically linked to the mechanical operations of your circuit breaker. So we sell literally hundreds of thousands of these switches into the OEM market for circuit breaker operation, auxiliary switch control. And with that, if there aren't any questions, I'm going to turn it over back to Ashley and the folks at Springfield.
Well, Wayne, we want to thank you at this time. I think we might have time for 1 or 2 questions here.
All right, yeah, one of the questions that came in, what are the most common utility switch types?
The most common utility switch types are definitely the lockout relay, the ANSI 86 relay, and then there's a function called the 43 switch. It's a local remote switch, so that could be a selector switch for local and remote operation. Another definition or another style of switch is the raise and lower for a tap changer on a tap changer control. You might want to raise and lower taps on a transformer. So there's a function that we sell a lot of switches in the local remote, or the raise and lower function. In bridge controls, we sell switches that are used for raising and lowering switch, dual leaf bascule bridge controls that are used in those applications. So I would say those are the 2 most popular mechanical switches. And then of course there's the electrical version of those switches.
One last question that came in, you may have already addressed this, but what are slip contacts?
Slip contacts, I tried to mention that earlier when I showed you the blade on the assemblages. But essentially, a slip contact is a contact that is a fatter contact, and it overlaps 2 poles or 2 positions on a rotary switch, so that I have a make before break configuration. So the thickness of the contact overlaps 2 adjacent poles. So as they rotate, they're both closed at the crossover point or at the sharing point. And then when I get to the center of the second position, the first position is disconnected while the second position is just connected. So it's a very close way of giving me a sliding, slipping action of a contact that allows me to have a closed contact before the previous contact opens. You know, in current transformers, you cannot really open circuit a current transformer because you have such magnetic potential already built up on it. If you leave that circuit open, it can cause either damage or failure to or harm someone, because there's a magnetic voltage built up on that current transformer. Hopefully that answers the question, and I do have some visuals that I could send anybody who is looking for more detail on how a slip contact operates.
Well, Wayne, thank you for that. Real quick, if you have a slide, could you put up your contact information for those that might want to reach out and get in contact with you? Or if you don't have a slide, maybe just do a quick mention.
Okay, I don't have really a slide offhand that I can put up there, but my email address is WKANTAREK@electroswitch.com, and my number is 781-660-0120. I'm located in the western suburbs of Chicago. This is my field office, and I'm more than happy to take any calls and help design or troubleshoot any switch applications you might have.
Sounds good. And for those of you that were not able to maybe jot that information down, feel free to reach out to myself, Brian, or Ashley, and we'll definitely make sure we get you in touch with Wayne. Wayne, I want to thank you for the physical demonstrations that you provided today. And, you know, I think I speak for everyone when I say that it's really appreciated, especially in the climate where we can't be in person and kind of see some of these devices. It sure was nice to kind of put the camera on those and see that physical demonstration. So we really appreciate that.
Great. I am happy to do it, and I can do it one-on-one for other people. And, you know, looking at the switches, it's, you know, a picture is worth 1,000 words. So if anybody wants to do a web chat with me, I'd be happy to do it.
Sounds good. Well, again, we appreciate your time. Just a real quick reminder, next Tuesday, February 2nd, will be our final 4 in the second series of AIEC Webinar Week. So be on the lookout for an agenda for that. And, you know, if you find something interesting, please go out and get yourself registered and signed up. If you've already attended a webinar, you will be eligible with that attendance and the successful completion of a survey that Ashley will be sending out after the completion of our final 4. Fill that survey out and get your name in the drawing for our grand prize giveaway. With that concludes today's webinar series. Thank you all for attending, and we hope to see you on February 2nd.